Laboratory 1A, Pump Performance. In this laboratory, we're going to be looking at 4 different pumps. We're going to be looking at a flexible impeller, a centrifugal pump, we'll be looking at a gear pump, and a screw pump. Now, over the unit operation class, we'll be using a variety of pumps to move water, to move air, to move Newtonian and non-Newtonian fluids, all in the different laboratories. In this laboratory, we'll be examining specifically the performance of some of these positive displacement and kinetic energy pumps as related to the pressure, flow rate, energy used, all of the different characteristics. When you're completing this lab, we want you to think about some of the other laboratories and how the pumps are used to move water either into the distillation column, into the evaporation chamber, into the spray dryer. All of these use pumps in a slightly different manner, and we have chosen different pumps for different applications, as you will do once you've entered industry. So keep in mind some of the characteristics that you'll be seeing from the pumps as you complete this laboratory. Conceptually, this laboratory is fairly simple. We have a reservoir of water and an apparatus containing 4 pumps. You must make sure that the valve before the pump and after the pump that you'll be using are turned on. You'll be assessing 1 pump at a time. After the water will be drawn by the pump, or first through gravity, then through the pump. Through the pump, you'll be reading the pressure at the inlet of the pump. The water will then move up through a rotameter and back into a reservoir. There will be 4 objectives for this laboratory. The first objective will be to compare the performance curves for each pump. Second, you'll be looking at the energy provided and the efficiency. For each pump, you will be collecting the pressure, the flow rates. You also have the amount of power consumed by the pumps, provided to you in watts. Next, you'll be looking at the net positive suction available by the pump and be comparing the valve loss coefficients and the flow rates. Now let's go down and look at the apparatus, and then you'll have a better idea of what we're working with when you come into the laboratory. Laboratory 1A, pumps. In this lab, as mentioned in the introduction, we'll be examining 4 pumps. We have screw pump, we have our gear pump, we have our flexible impeller pump, and we have our centrifugal pump. We'll be operating these pumps 1 at a time. As with our fluid flow laboratory, we'll be dealing with amounts of electricity, water, and we're on a landing. We'll be working above other students performing unit operation laboratories and below students. So we must keep in mind that we are in an open environment that requires all manner of apparatus, or all manner of personal protective equipment, from steel-toed shoes, all manner of personal protective equipment. We will require all manner of personal protective equipment, including steel-toed shoes, lab coat, safety glasses, and hard hat. Before we begin the laboratory, we must first pull back the master shut-off. If at any time during the laboratory there is a problem with the pump, or if there's an emergency, press this button and all of the pumps and electricity will stop. So in order to begin, we'll be examining the characteristics of each pump by looking at the amount of fluid flow through the rotameter, the pressure at the inlet of the pump in PSI. Make sure that you recognize whether this is gauge, absolute, and to use accordingly in your calculations. We'll be selecting through 4 pumps, 1, 2, 3, and 4. However, and we'll be looking at the amount of volts, amps, and watts. By looking at the bulk fluid flow, we know the characteristics at this temperature of the fluid that we'll be pumping through. We will know the pressure at the inlet of the pump, and we'll know the type of pump. With all of these together, we can fully characterize, look at the performance of the pump, and of the system. We can look at the energy delivered to the water, and we can extrapolate based upon these findings to the other laboratories where we will be using each one of, or several of these different types of pumps in the various unit operation laboratories. So, in order to turn on the first pump, or any of the pumps, we must only operate one pump at a time. All of the valves will begin the laboratory in the off position. In order to activate the screw pump, we must turn on the inlet valve and the outlet valve. On each one of the pumps, the inlet and the outlet are directly connected closely to the pump. Secondly, we will check the apparatus, or the reservoir of water located behind the apparatus. And we must make sure that the intake for the water is located below the water line within the reservoir. Once we've checked that there is water within the system, the valves are open, we can select the first pump, which is the screw pump, and we will turn on here. As noted in your laboratory manual, for the first two pumps, it makes more sense to choose the pressure and look at the associated flow rate, and to choose multiple pressures in order to fully characterize the system. The reasons for this will become apparent as you begin to adjust the flow rate. Now, the screw pump, as shown in your manual, is a fixed volume pump. It'll screw, as the screw rotates, it'll drive a fixed volume of water through the opening and back up and through. Actually, currently we have 10 psi, flow rate of 1.5 gallons per minute, 120 volts, 1.8 amps, and we're currently consuming about 64 watts. All of these together will help you to characterize the characteristics of this pump over a volume of flow rate. When look, yep.
Sorry, can we do that again? Also, you said 64 and it's reading 84.
Aha, thank you.
So maybe I'll just zoom in on the meter there.
Yep. We're at about 120 volts, 1.8 amps, and approximately 83 watts. All of these values together will help us to characterize the pump for this given flow rate. Now, once you have several different flow rates and pressures, you'll be able to extrapolate what applications this pump is best suited for, what volumes of flow rate that this pump can handle, and in what situations, given a value of input and output pressure, that you can apply this pump to in an industrial setting. This pump, the screw pump, we'll be using again when we go to the spray dryer apparatus during the winter term. The second pump, we will select the second pump accordingly, close the valves to the screw pump, open the valves to the gear pump, ensure that there's slightly opened the rotameter, and we can begin the flow rate through the pump, through the apparatus. Now this pump is again a fixed volume pump, positive displacement pump. We are pushing through via gears a set volume of liquid depending upon the speed that the gears are flowing. As we attempt to increase or decrease the flow, you will see the pressure change accordingly. Keep note that for the first two pumps, you restrict the flow using the rotameter, and you'll look at the associated pressure difference within the apparatus. This will give you a clue into characterizing the pump and deciding applications that this pump is good for. If you're curious about the design of the pump or why certain changes affect one parameter but not another, look up the pump using the serial number provided on the physical apparatus. This will give you a better idea of the internal makeup of the pump and the full range of operating conditions that it's suited for. When moving to the flexible impeller pump, in this apparatus, you, instead of adjusting or restricting the flow and then reading the pressure, you'll now be adjusting the flow and looking at the associated pressure. So whereas you are restricting, looking at pressures and looking at the associated flow, you're now looking at the flow and looking at the associated pressure. This pump, due to its internal design, will be very good for certain flow rates, however will begin to taper off as you approach a specific flow rate, which you may or may not see in this experiment. Look for the reasons of this in the literature and attempt to compare to what you see during the experiment. Remember to set a flow rate, look at the associated pressure. In the final apparatus, the centrifugal pump, this is a pump type that we use in multiple unit operation labs for both gas and water. The flow rate to the front of this pump is controlled via two rotameters connected in parallel, similar to the pipe friction laboratory. When using the flow rate, make sure that you have the combined flow from both. As a final note, for each apparatus, make sure that you note where the water comes in, where the water comes out, and where each measurement is being taken from. The apparatus is open on the front and the back so that you can get a full idea of how the apparatus was constructed and what measurements you're actually taking so that you can use them properly in the report.